So this is the first of our revision classes in linear motion, and we're starting with type 1 motion under gravity. So these are always nice little questions. They don't come up too often, but when they do, we have to be careful about keywords like distance versus displacement in terms of the object that's going to be thrown up into the air and then coming back down, or sometimes even the object is dropped out of the air and reaches the ground, or sometimes you could have two objects being fired at each other. So once they're in a state of free fall, they're considered to be motion under gravity. So again, if the object is projected up into the air, then it's moving against gravity. So in that case, we'd actually give the initial velocity a positive value. And if you do that, that means that g would be in the opposite direction to the initial velocity, and therefore it would be given a negative value. So little things like that to remember. Now, if the object reaches the highest point off the ground and is being projected upwards, then at the highest point, the maximum height reached would be when the velocity in the y direction is 0. So it'll continue to have an x direction velocity, as we know from projectiles. Okay, so let's have a look at the diagram here in the question. So we have a ball thrown vertically upwards. So I'll just draw the ground, and I'm going to draw my object, and that's going to be projected upwards. And we're given an initial velocity of 39.2, and that's meters per second. And then as it goes up, it will obviously come back down again. So we're asked to find the time taken to reach the maximum height. So therefore we know this is our maximum height. And that's going to occur when the velocity will be equal to 0. And we know then that u is 39.2 meters per second. So because we're giving that a positive value, as we said a minute ago, we're going to assign g a negative value. So, sorry, I should say a there. So a is equal to minus g, in other words, minus 9.8 meters per second squared. And we know that the final velocity when it reaches its maximum height will be 0. And therefore we can obviously see that if we have v, we have a, we have u, and we're looking for t, then we're going to use the equation v is equal to u plus at. So by subbing in our values, we have 0 is equal to 39.2 minus 9.8 t. And by rearranging to get t in its own, we end up with the time taken to reach the maximum height is 4 seconds. Okay, so if we look closely at part 2 of the question, we have two things to note here. We're asked for the distance travelled, so that means the distance up and the distance down, because it says the time is 5 seconds. Now 5 seconds is more than a time it took to reach the highest point. So if we look at the first part, we have 4 seconds is the time to reach maximum height. So therefore it's gone up for 4 seconds and it's on its downward path for 1 second. So we're going to be roughly somewhere along here is that the distance that's going to travel. So that means it has to go up in my diagram and come back down. So often what students do is they work out S and the displacement, but the displacement would be from the start to the end point, and therefore it would actually be the difference between those two values. So please be careful here. It's not displacement we're looking for, it is distance. So again, I'm going to double, treble underline that word in the question. So therefore we need to look at the up stage of the journey first. And for going up, we know that u is equal to 39.2 meters per second. We know that the acceleration is minus 9.8 meters per second squared. And we have already worked out that the time taken to reach the height is 4 seconds. So therefore, if I'm looking for S, sorry, go to that line. If I'm looking for S, I have U, A, and T. Well, clearly I'm going to use our our equation S is equal to UT plus a half AT squared. So for subbing in the values, we have 39.2 times our time 4 plus a half times minus 9.8 times 4 squared. And putting all of that into our calculator, we end up with 78.4 meters. So that's for the upward direction. So now we have to look at, well, what's happening on the downward path. So if I just move that up. So if we're coming down, lines appearing everywhere. So if we're going in the downward path, well, what can we say? Well, if we're looking from start to end, the initial velocity would be 0, because that was the final velocity, but that's now the initial. And because I'm starting at U being 0, then I'm now going in the downward direction, the same point as gravity. So because I'm taking these parts of the journey in two separate stages, I'm saying U is 0, and now I'm heading down. So therefore this time G will actually be positive, because it's in the same direction as the initial velocity for this stage of the journey. And we're looking for 1 more second, because we've already done 4 seconds, and the total time for travelling here in this question is 5 seconds. And again, we're looking for S. So it's the same equation. S equals UT plus a half AT squared. And then if we sub in our values, we have S is equal to U by T plus a half by A by T squared. And then that gives me 4.9 meters. So therefore we say the total distance, not displacement, the total distance would be the sum of the two of those together. So my distance travelled is 83.3 meters. I'm just putting in D there instead of S, because obviously normally we would use S for displacement, okay? So just again highlighting that is the distance in 5 seconds. Okay? So in terms of marks for that question, it was a 20-mark question. So it was 5 marks for getting your 4 seconds. There was 5 marks for working out the upward part of the journey. There was 5 marks for getting the downward part of the journey, and then 5 marks for adding the two together. So a really nice little question, that.